model enables Stereoplotter, which have been fitted with encoders to capture data digitally. Full orientation procedures are included with a least squares adjustment. Projector plotter. Diapositives of a stereopad are placed in projectors and illuminated from above. The light rays are projected through the projector lens and intercept below on the platen. The function of the viewing system is to enable the operator to view the stereo model three-dimensionally. The left eye views only the overlap areas of the left photo, while the right eye sees only the overlap area of the right photos. The analogic system uses red and blue-green filters to separate the left and right projectors. A blue-green filter is placed over the sources of light of the left projector, and a red filter over the right projector. If the operator wears a pair of spectacles, placing of the blue-green filter over his left eye and red over the right eye, he will be able to see the stereo model in three dimensions. Another variation of the system is called the SIA, or image alternator. This system does away with the glasses. Another system is called the PPV, which uses polarizing filters instead of the color lens. The optical trend plotter creates a true three-dimensional model from which measurements are taken by projecting the light rays optical through an optical trend to a binocular for viewing. This is half-silver mirror. This is for function for drive motor. This is function division camera. This is contain marking, pencil and control, elevation control and map reader. This is X drive motor 32. This is button for sweep processing computer and drive.
Those, they do not require any external source of energy. These are cheaper and portable. These are of robust construction and compact design. The simple linear scales are easy to read. These are unaffected by variation due to external sources of energy such as air, electricity, etc. Meanwhile, the cost is range is limited as the pointer moves over a fixed scale. Pointer scale system used can cause parallax error. There are a number of moving parts which create problems due to friction, and ultimately the accuracy is less. The instruments may become sensitive to vibration due to high inertia.
The basic principles of mechanical projection are illustrated in this simplified figure. Diapositive, which is the transparent image in carriers, are illuminated from above. The carriers are analogous to projectors of direct optical projection instrument. Two space rods are free to rotate about gimbal joints O' and O', and they can also slide up and down through these joints. The space rods represent corresponding projected light rays, and the gimbal joints are mechanical projection centers analogous to the objective lenses of projector of direct optical projection stereoplotters. The model exposure stations are therefore represented by O' and O', and the distance O' and O' is the model A base. Joints O' and O' are fixed in position, except that their spacing can be changed, either physically or theoretically during absolute orientation to obtain correct model scale. The viewing system consists of two individual optical trains of lenses, mirrors, and prism. The two optical paths are illustrated by the dashed line. An operator looking through binocular eyepiece along the optical path sees the diapositive directly and perceives the stereo model. Objective lenses V' and V" are situated in the optical trains and directly beneath the diapositive. The lenses are oriented so that viewing is orthogonal to the diapositive. Consequently, the diapositive image planes can lie on the upper side of the diapositive glass with no refraction error being introduced because no rays pass obliquely through the glass. A reference half mark is superimposed on the optical axis of each of the lenses V' and V". Movement is imparted to the lenses from the space rods by means of the tie rod
set at the tracing stand. Manually moving the tracing stand imparts movement to the space rods, which in turn impels the viewing system and makes it possible to scan the diapositive. By manipulating the tracing stand in the X, Y, and Z direction, the optical axis of lenses V' and V" can be placed on corresponding images such as A' and A'. This will occur when the reference half marks fuse into a single mark that appears to rest exactly on the model point. If orientation of the instrument has been carefully performed, with the floating mark fused on points A' and A', the space rod have the same orientation that the incoming light rays from terrain point A had at the time of photography. At the intersection of space rods locates the model point. Each additional model point is located in the same manner.
Comparison, the mechanical projection system illustrated in this figure is exactly the same as direct optical projection. Diapositives are placed in the carriers with their overlapping areas toward the outside. In scanning the diapositive, if the tracing stand is moved to right, the viewing lens move to left and vice versa. Also, if the tracing stand is pushed backward and the viewing lens move upward. Also, if the tracing stand is pushed backward, the viewing lens move forward and vice versa. When the tracing stand screw is turned to raise the space rod intersection, the parallax angle increase and the viewing lens move apart. A manifestation of the increased X parallax which exists for higher model points. The carriers of most mechanical projection stereoplotters are capable of rotations and translations, either directly or indirectly. These carrier motions are used to perform relative and absolute orientation. Many mechanical projection instruments are oriented by using exactly the same procedures that were described for direct optical projection stereoplotters. Others that do not possess all 6 rotation and translation use slight variations from these basic rotation procedures.